All right, let's get rolling. I hope everyone is even half as excited as me about this being the last session. I'm going to be able to sleep. It's going to be amazing. Let's do it. Let's get rolling. Um, that's not my PowerPoint. That's not my updated PowerPoint, at least. Let's reshare. There we go. Life is perfect. Life's not perfect. That's too small. Make it bigger. There we go. There we go. Life is good. If you come in and there's no audio, it's because it's playing from the beginning, which is very exciting. Now that I know after last time when it was choppy, it just, some folks are 5 minutes behind. So thank you for joining me for the last and final practical AI for perhaps investigative journalism. Today, we're going to be mostly talking about transcription, but it's all kinds of different audio stuff. Let's see, how many folks? All right. So, if you happen to be here for the very first time, great. If you've been here 100 times, also congratulations, because we're not going to do the same sort of review that we normally do. Because audio stuff doesn't need all of that. If you would like to get the materials that we are talking about today or any of the previous sessions, head on over to bit.ly Practical Journo AI, and it is a Google Drive link that has all the stuff. I will be updating better things for session 5, probably this weekend, along with all of the materials for today after this class. So one thing I learned from last session is don't always try to code live. So today I have so many little beautiful screenshots of code, and there are like 2 things I'm actually running live. So we should have fewer things happen that get in the way of us being remarkably successful. So what are we doing today? We're doing a short intro to audio models and ASR, automatic speech recognition. We're talking about a specific model called Whisper for pretty much all of today. We're going to talk about how to pick a specific Whisper model, how to run it both from a graphical interface and from Python or the command line. We're going to see how else you could transcribe using tools like Otter or DeepGram or even YouTube. And then we're going to move into some advanced features, so things like speaker diarization. And then finally, when you are trying to transcribe material or when you're trying to work with video or audio, there are always a lot of other tiny little tools that end up being useful. So we're going to talk about YouTube DL or YTDLP and also FFmpeg. So knowledge of those 2 tools is going to make you infinitely more powerful. And then finally, very tiny bit at the end, we're going to talk about text to speech and deep fakes because everyone loves a good deep fake. So let's get started. What we have done 99% of the time so far is we work with models, but pretty much all of the models that we work with are chat models, where we say, hey, let's have a party that involves me typing into a box. It heads on over to the chat model and it gets a response. As we've talked about maybe the past 2 sessions, models are just a general category, or AI is just a general category of this little box that takes some sort of input and gives some sort of output. So in this case, chat model takes in a prompt, gives out a response. For what we're going to be doing today, it's going to be a transcription model. It's going to take in some sort of audio and then spit out some sort of text. The fun thing about today is we are going to leverage everything that we have learned over the past 5 sessions. All those tiny little buzzwords and things that got dropped in, they're all going to be useful this time to make you much more powerful when it comes to transcription. Now, the reason why we focus so much on text is just the most useful thing that's ever been invented. Pretty much every kind of task that exists can be done using text. Even if we start to do things with transcription or video or any of that, we usually end up with some sort of text output that then we can summarize or classify or something like that. So if we want to write poems about my cats, or we want to analyze sentiment of new Coke, or we want to extract people's names from a text, it's all text. It's all text. But today, we're dealing with audio. And the reason why we're dealing with audio, because this is a supposedly investigative journalism session, there's literally just one thing, maybe two, maybe three, but it's just you want to transcribe all of your interviews. You want to transcribe your interviews, and that is the reason why you are going to use an AI tool that is an audio model. That's just it. And I promise that even if you say, I use Otter, it's great, life is perfect. I promise your life is not great. Your life is not perfect. We are going to make your world incredible. Not even by the end of this, in like 5 minutes, maybe 15 minutes, you'll be like, wow, I can't believe I ever thought I lived a good life. So, audio models and ASR. Now, the thing that irritates me about talking about transcription is that it is called ASR, which is automatic speech recognition. This is the Hugging Face list where you can click things and, filter for the models. The reason why I don't like calling it automatic speech recognition is because so often you have things that are text to image, image to text, text to speech. Why is it not called speech to text or audio to text? Why can't it be that? Why can't it be that? But alas, on my end, the microphone says it's almost peaking, almost peaking. So if other people are having issues with the volume, I can try to up it a little bit. Here, why not? Why not? Here we go. Gain goes up. Gain goes up. There we go. Now I'm up in the yellow zone, which seems dangerous. All right, so audio models, ASR, it's a delight. Now, when we worked on local models, it was a delight. Facebook has a local model. Microsoft has a local model. All of these different, I don't know, corporate entities, shall we say, are releasing all of these local models. And you love them, and they're so much fun, and you can run code on your own computer without giving up, sending things out to OpenAI and getting responses there. So great question from the chat. How do these models compare to Trent? Because your company pays for Trent. I am not going to show you how it compares to Trent, but I am going to show you how to do a perfect job making a comparison chart between the tools we look at today and any sort of model that you might be running from some sort of pay for service. Spoiler alert, the free stuff ends up being better most of the time. So with these local models that we love, OpenAI, GPT, it is not a local model. It is not a freely available open model. When we go to ChatGPT, we type in a box and we say, hey, can you tell me how to do something? Our message goes off to OpenAI. They peek inside, they look at it, they shuffle it over to GPT, they get a response, they send it back to us. We cannot run GPT on our own computer, which is why we had to go through jumping through hoops to download Llama 3 and things like that the other day. But if you look at OpenAI's name, open is part of the name, right? And so you'd expect that a company that has open in the name is going to produce open models. And it turns out initially that was kind of part of somewhat the goal of OpenAI. And that is why they're being sued by Elon Musk, because the one thing that he said was like, no, not the one thing he said, but the one good thing he's done on this planet is say, hey, you said you were going to make all these open models. You said you were going to be sharing all of these things, but instead you took this nonprofit and then you spun off a for-profit company, and all this stuff is very sketchy, and now I'm suing you. And so what have they ever done anything? They produced GPT-2. GPT-2, a terrible GPT. It was back in the day, people were excited about it. And they said, when we release this, the world is going to end. And now we're several GPTs later. The world has not ended. And that was the only GPT that they did release to the world. But in 2022, they did release an open audio model. So not a text generation model, not a chatbot, not a large language model. It is called Whisper, and does transcription. It takes audio of human speaking, or probably anything speaking, robot speaking, animal speaking, and then turns it into text. And this is a local model. If you go on Hugging Face and you search OpenAI Whisper, it has all of those models there for download, just like you could download that Facebook model we used for classification, or just like you could download Llama 3, and just like you can't do with something like GPT. So, in terms of what we mean by I'm saying Whisper is open, the weights are open, so you can just download it and run it, and it's fine. And the license is open. There's no restrictions about what you can do with Whisper. You don't know everything that it was trained on, except you do know it was trained on YouTube videos, and we'll talk about why later. And we don't have the architecture or code behind the model, but we have all the stuff that we need in order to make things with it. And when I say things, some of those things are actually other models. So if we look here, there are other models people have made that are built on top of Whisper. And we'll talk a little bit more about those later. But this is really as open as you can reasonably get from something like OpenAI. Additionally, there are all kinds of different tools that you can use for this. When someone releases a model for free out into the world that anyone can run, large language models, large is in the name, it was kind of tough to run them because they were like 70 billion parameters. We're downloading like 60 gigs of information on our computer and trying to run it all at once. And our computer's like, please don't do this to me. Whereas the audio models are much, much, much smaller. So pretty much anyone can run them on their computer to varying degrees or varying speeds, but anyone can run it more or less. And so as a result of this, a lot of people have released tools that also help you run Whisper on your machine. And so we're going to start, we're not going to use Google spreadsheets for this, but we're going to start with graphical versions, ways that we can run Whisper without having to run code or type code. And I'm going to throw a few links into chat. I'm putting 3 links into chat, 4 links into chat. It is not letting me send all of these. I'll do them one at a time then. All right. So first up, we have Mac Whisper, which is a interface where you can run Whisper on a Mac. It is the best piece of software that has ever existed. We have Easy Whisper, which seems slightly worse. The Windows world for this stuff is not as good as the Mac world. I'm sorry. We have a Hugging Face space if you don't even want to download anything on your computer. We have Whisper Jax, which is a version that runs in the cloud for free. And then if you want an MP3 to sample this out, you can go on that Google Drive link and you can download an MP3. And yeah, so Mac Whisper is good. It is cheap, and there's a discount for journalists. And the most important thing about something like Whisper is you are downloading these models and running them on your computer, which means that you do not have to use someone else's cloud service over time. And just like Jeff said, it is a one-time license, something that used to be the norm, but now is not the case. Now, anytime there is something useful out there, you have to pay for it every single month, thousands and thousands of dollars. But for Mac Whisper, also for Easy Whisper, you just pay them once, and then it is good for forever. So life is perfect here. And if you don't, I mean, these both have free trials or tinier versions that don't do as good or have limitations on the duration of things that you can transcribe. But if you just want to run something in the cloud for now to see how it goes, just run WhisperJax. Perfectly fine. Won't be an issue. All right. Now, when you open up Mac Whisper, I recommend that everyone right now, you download this so you can kind of see what's going on. It has all these features for the free version. And then one of the features, it says supports tiny, base, and small transcription qualities. And you can compare the transcription quality between all quality levels. And you say, what is that? What does that really mean? I don't really know what they mean by that. And what is better than this? Large? Big? Now, it turns out that when you have Whisper, just like when we were working with large language models and they had different parameters. Question from the chat, what is a parameter? Does 70 billion parameters mean it was trained on 70 billion sentences or something like that? No. Think of it as like how big the brain is of the model. So the more parameters that are in it, the bigger it is, the more intelligent that it is. Not necessarily the more intelligent. If it's the same architecture, a 70 billion parameter will be smarter than an 8 billion parameter. But just think of it as like the number of inputs or the number of things it thinks about at one time. I don't have a good way, just it's bigger. It's bigger and better the more parameters that are in it. So, if we look at Whisper, there is not just one Whisper model. Just like the large language models, there are larger versions and smaller versions. When I was running Llama 3 70 billion parameters on my computer the other day, it was so slow, so slow. My computer was like, look, I can do this, but I'm giving you like 2 words a second, and that's the best I'm going to be able to do. Whereas when I was running the 8 billion parameter version, a much, much, much smaller version, it was just spitting out text like crazy. So it's the same thing here with Whisper models. The larger the model is, the better it is at transcription, but also the slower it is. So if you have a very fancy computer or even a moderately fancy computer, you can use the large version. But if accuracy doesn't matter, if you need like real-time transcription, maybe tiny or base, those much smaller versions are going to be good for you. A great thing about Whisper is if you look at the different models, there are 2 columns. One is English only and one is multilingual model. And what that means is there is a version of Whisper that just works for English, but then there's also a version that works for all of the text that exists out there, all of the languages that exist. Because in the same way that a large language model just ingests a ton of text and figures out patterns and starts talking in whatever language it has seen, it's the same thing here, where it has ingested a ton of probably YouTube content. And on YouTube, people speak all sorts of languages. And as a result, it kind of somewhat, in theory, a little bit knows these different languages. So we're looking at a score here for different languages. And so it's great at Spanish and Italian. It is slightly worse at English. And as we go down this list, it gets worse and worse and worse. And I don't want you right now to know what this actually means, like what this metric is, because it doesn't really matter. Usually speaking, even if it says it is good at a language or bad at a language, you have to test it to see if it works. You have to say, does this work for my use case, for my quality of recording, things like that. But an excellent side effect of the fact that it knows these other languages or is trained on so much data is that it is really, really good, even if we're just talking about English, at accented English. So many times, if someone speaks English as a second language, or even if they're from like the South or something like that, they come in and they have a little bit of an accent or a lot of bit of an accent, or they're speaking, a style of English that is not, United States-based English, and suddenly these models can't do a good job transcribing their speech, and it kind of it's rude. I don't know. It's not the world we should be living in. But because Whisper has all of this data and is as good and smart about the entire world, it is great at transcribing accented English. So if you're someone who either interviews people who might have accents or you have an accent yourself, you will find that this is a delight. So let's try out Whisper. I am going to move this guy off my screen. I am going to open up. Wait, let me make sure that my next slide is. Okay, great. And perfect. So this is our good friend Whisper here. This is Mac Whisper specifically, but if you are using Easy Whisper or any other tool, the same questions that we're about to be confronted with are the questions that you will be confronted with. So if we click Manage Models here, this is the screen that comes up automatically. And what this is saying is, look, you can transcribe many different ways with many different models, as we saw before. And the thing you have to do is download the different models to your machine. I've already downloaded a lot of these, and I'm not going to download them again because I want my streaming to still be able to work. But if we see this, it describes the model. So base, just for English, is fast with decent accuracy, whereas large is very slow but with amazing accuracy. There's another one called Large Version 3, and it is really, really good, but sometimes it goes wrong and it just starts repeating text, which is very funny. Um, so, we could stick with large here. If you want to, I'm going to try to play this so you can listen to it. I think I turned on my capture for audio for you, so I'm just going to play this and we'll see what happens, and hopefully it doesn't have a terrible echo.
This is the Micro Machine Man presenting the most midget miniature motorcade of micro machines. Each one has dramatic details, terrific trim, precision paint jobs, plus incredible micro machine pocket playsets. There's a police station, fire station, restaurant, service station, and more. Perfect pocket portables to take any place. And there are many miniature playsets to play with, and each one comes with its own special edition.
So that audio, pretty hard to transcribe, one would think. But if we look at the large model, it seemed to do a pretty good job. If we look at the base model, which is going to be faster, or I forget, do you get base for free? Let me scroll down in here. If you don't pay them, yeah, tiny base and small. So you could run base and it does a decent job. Tiny does a much worse job. This is the Micro Machine representing the most miniature motorcade of Michael the Team, not miniature motorcade of Micro Machines. But that's fine. It's pretty hard to transcribe. If you want to actually transcribe text, all you need to do, I'm going to open up my nice little in-class things. I have an MP3 right here. I drag it on over, and now it's going to start transcribing. This is an MP3 that is about 10 minutes long, and it is a conversation. We're going to talk specifically about what it is later, but it is going to be done in about 1 minute. So this is running on the large model. I believe this is specifically large version 2. So it is almost state-of-the-art accuracy. I think large version 3 is probably going to do a little bit better, but 10 minutes long, transcribes in maybe a minute, maybe under 1 minute. So I think that's a pretty good rate. It's not going to do things real time, but it's pretty good. And it goes and 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 goes. This is one of the only things I trusted to actually work in real time because Mac Whisper is so nice. So nice. So if you want to export this, save it later, you can export it as subtitles. You can export it as little segments that say, like, what Whisper does is it kind of chunks the text into these little segments, which sometimes end up aligning with different speakers talking, but sometimes it just kind of chunks it wherever it feels like a chunk should be. And yeah, so you can do it as subtitles if you want to put it on a video or anything like that. Now, if we go back here, that is generally what happens in these things. Mac Whisper also has a lot of little extras. Does anyone here clean up their transcriptions? Or, yeah, clean up their transcripts. I call it transcriptions all the time. It's embarrassing. With ChatGPT. Does anyone, like, take all of the text that comes out of a tool, like Otter, and then you throw it in and you say, separate it out? Now, there is a plugin. Oh, don't steal my API key. I guess I'm going to have to remove that later. There are all of these prompts that allow you to extract questions, highlight key points, improve grammar, summarize, bullet points, things like that. So whereas Whisper itself, Mac Whisper, is going to run on your computer, it will also potentially send it out into the world. Now, let me see, is this the next slide? We'll talk about this later. But there is the question from chat, does it separate when there is more than one speaker? Now, right here, one of the things inside of ChatGPT section, it says this is a transcript between multiple speakers, group each section with a new line. Now, the problem is that you will think this is actually separating speakers, but it's not. It's just saying, hey, GPT, Make a guess. Make a guess at where this changes between speakers, because all GPT is getting is the transcript. And so if you ask a question and then get an answer, and ask a question and get an answer, it might be obvious what the different speakers are. So it might work pretty well, but it is not actually looking at the audio file. But in terms of seeing how good it performs, honestly, like I recommend just giving it a shot. Just give it a shot, upload it, and see what happens. Because as much as they can say, here's how we're scoring it, it's this good, it's this bad, you never really know. You never really know. Let me open up what I recommend doing if you are one of the people right now who's like, I want to know right now. What I recommend doing is go to this link. I'll throw this link in the chat again. Go here, click record from microphone, and just talk. Just talk into it and see how well it does the transcription. It should work pretty quickly, and you'll see whether it works for your accent or someone else's accent if you want to drop a file in there. So give it a shot if you want to give it a shot. I'll give you a couple seconds of silence if you want to slam that record from microphone button. All right. So that was Mac Whisper. Like that is it. Like you click that download button, it downloads a large model, and then you are good to go. So next up, maybe you're like a cool programmer person and you say, what I really want to be able to do is not have to drag and drop something all the time, but rather I want to be able to use code. Me, for example, I love transcribing local government meetings. It's my favorite hobby. And so what I end up doing is I run Python code or I run command line code in order to do that for me. So if we want to run Whisper from code, if you go to the official website of Whisper on GitHub, um, it understood Russian, kind of. It translated grandma as baby. So one of the things that, when you are using Whisper, it transcribes, but it also claims to translate. And I don't know if you meant that it transcribed grandma as baby, but then I don't know if I trust all of its translation abilities on top of its transcription abilities, but yeah, go wild, go wild. So if you want to use Whisper, you can just go download it and then life works great. And like, how many lines of code is this? Honestly, it's just 2. You just pip install and then you run it and life is perfect. But because Whisper, like I said, is very, very open, there are all kinds of other things you can do or other tools that are available to you that work better. We're going to go through far too many of them. Trying to find the one that works best for you is the worst nightmare you've ever encountered. So, if you say to yourself, I wish Whisper were faster, there is something called Faster Whisper, and it runs Whisper faster. We see these lines here where it says device equals CUDA and else CPU, and also compute type int 8 or compute type float 16. We're going to see these things later, well, starting now and also later. When you're talking about running AI models, we should have talked about this in the local models class, but there's kind of 3 categories things can go into when you're running it on your hardware. Number 1, you just have a bad old computer and nothing is fancy about it, and that is CPU. CPU is probably as slow as it's going to get. It's not very fancy. It's not very good at math. Also, your compute type is going to be int 8. Secondly, if you have, let's say, an M1, M2, M3 Mac, that is a slightly fancier version. The way that the computer is built kind of allows it to do AI things more easily than more of a traditional computer. Now that sometimes is also CPU. It's also int 8, but it runs things faster. Sometimes MPS we're going to see as the little bit of a buzzword there. The third and best way to do this is if you have either A, you're running code in the cloud on Colab, which we'll talk about, or if you have a fancy NVIDIA GPU, that is going to be the CUDA thing or float 16. So depending upon the way your computer is set up or the system you're working on, you can tweak this code to make things perform better or worse. And that's part of the trouble is previously we just said load it and run it and we're good to go. But if you really, really, really want to optimize your ability to push things through quickly, you kind of have to learn what's going on inside your computer and what works and what doesn't. And some of this ends up just being experimentation. If you made this float 16, or if I made this float 16 and tried to run it on my computer would give me an error, whereas Innate is fine. And also, you're like, I'm never going to remember any of this. Don't worry. It's all on the first page of the documentation for every single one of the libraries that we're talking about. So I'm not just dropping this on you and then running away. So if you think faster Whisper is not fast enough, there's also insanely fast Whisper, which is supposedly even faster than fast Whisper. And if we look at it, the code is a little bit more complicated here. You can actually run it from the command line, and it is very simple, and that's usually the way that I do it. But if we want something faster than faster Whisper, we do have to deal with a little bit of slightly more troublesome code. And then if you're like, I don't know about insanely fast Whisper, that almost sounds too fast. There's also Whisper Jax. So Whisper Jax is not really so much of a thing anymore, but it is the one that is running that you saw that I dropped the link to that was running on Hugging Face. So it works very well on like Google Colab or other things that kind of live in the cloud. Then there's Whisper X. If you think that all of these things that are fast and faster, and you just say, I want something that feels cool. Whisper X is, again, you see that same torch, CUDA is available. You see that same compute type thing. It's still that complicated stuff where if you want to get down into the nuance of making your code extra fast or extra slow if you type something incorrectly, you can play around with Whisper X. And then there's Whisper CPP, which is by the same guy where we were using Llama CPP at the end of the session the other day. Or honestly, for the local model session, when we were running LM Studio, or if you use any of those other tools, they are all based on Llama CPP. So the Llama CPP guy made a Whisper CPP, and it it's way more technical than anything else. You have to convert your MP3s to WAV files. You have to like make things and do all this complicated technical command line stuff. It's not really worth it. But something like Mac Whisper is actually built on Whisper CPP. So whereas it is very tough to use from a personal direction, if you build a little bit of a wrapper around it, it's very, very fast on Apple machines. But yeah, usability is not there unless, let's say, you're using it with Mac Whisper. Now, all of these, the way to know whether they are good for you or not is just to run them. Like if you're fine with the output of normal pip install OpenAI Whisper, it's fine. You never have to think about anything ever again. But probably you want maybe a little bit more speed, maybe you want a little bit more accuracy, but probably what you want is there was the question before about splitting up speakers, and speaker diarization is the one thing that everyone wants. It's the one thing that everyone wants, and it's the one thing that you will rarely get, at least not accurately. Trying to figure out who is talking is so hard. It's so hard, and it's actually slightly easier if you have video. But the real difficult thing is there's two difficult parts. One, speaker diarization, figuring out who is speaking, how many speakers there are, just like if it maybe it's 5 people, maybe it's 10 people, maybe it's 2 people. Sometimes you can say, oh, there are 2 people here, and it does a better job than if you say, I don't know how many people are in here. But it is just anything that you run is not going to be perfect. With this AI stuff, I think we're usually used to content being pretty good. And one of the surprising things that happened with local models is we were running the 70 billion or 8 billion parameter Llama 3 model, the small Llama 3 model. And it was giving us output that wasn't that good, or my fine-tuned model at the end there wasn't doing that good. And you're like, I'm not used to things not being good. Speaker diarization, hard, not that good. It's not going to be perfect. Sometimes it's best to just split it up yourself instead of spending the extra time making it happen. Um, we talked before about this. If you split into speakers in Mac Whisper, it is not actually splitting it based on the audio. It's not figuring out what everyone's voice sounds like and then sending it out. It is just sending this prompt to OpenAI along with the transcript. It's saying there are multiple speakers here. Figure it out just based on the transcript itself. Does that work? I don't know. Maybe it does. Honestly, sometimes it might work better than actual real live AI diarization. Now, the thing that most people use, these software packages that do speaker diarization, you're rarely going to find a graphical like drag and drop click around tool that does this. But something like WhisperX, WhisperX was previously my favorite before yesterday, and pretty much every single tool uses something called PyAnnote Audio, which is just a toolkit that is about speaker diarization. And it specifically is a model. It is a local model that you can find on Hugging Face. And it is a local model, but it's an open model, but it's a type of open model that we didn't talk about on local model day. It's what's referred to as a gated model. It's a model where you have to jump through some sort of hoop in order to use it. So you do get to download it to your computer, but you have to say, here's who I am. And in this case, you have to go on the Hugging Face website and you have to sign into Hugging Face, go to the model page and say, here's my email address. Here's what I'm using it for. Now you know. You get automatically approved, so it's not like someone sitting there trying to figure out who you are. Like my username on Hugging Face is Wendy's LLC. So I don't think the restaurant chain, fast food chain Wendy's, is actually using this for speaker diarization, but maybe the PyAnnote guy thinks that it is. On top of that, every time you go to use it, or if you try to use it with WhisperX, you need to put in an API key. So again, we're pulling in all of the things that we've done before. This is a local model for speaker diarization. We find it on Hugging Face. Is it an open model? Kind of. In order to use it, it's gated. We have to say who we are. And then when we go to fetch it from Hugging Face to run it locally, we have to say, here's my API key, or here's my access token. This is how I prove to you who I am. In the same way that we were doing with Claude, in the same way we were doing with OpenAI, because it's our computer talking to the Hugging Face computer, we don't just get to log in. We have to have this API key or this auth token. And so you run the code, it goes through, it works, everything's fine. Do I want to show it to you? No, not yet. Okay, yeah. Which one are we going to pick? So we can use CPU, Apple Metal, NVIDIA GPU. We talked about this before. There are so many settings for all of this. There's so many settings for all of this. It's a real pain. And what works, what doesn't work, you just have to run it and see. Honestly, it feels like a cop out from my point of view, but just try to run it. If you run into bugs, ask on GitHub, say help me, or just email me and say help me. Or most of these places have Discords where you can join the Discord and ask people questions. If you're interested in diarization, Whisper and Faster Whisper don't do any diarization. Whisper CPP does, it has a model called Tiny Diarize, which is apparently not very good, and it does stereo diarization, which is if you have this is good for like podcasting or something like that, something where there are two speakers, interviews maybe. If you put one person in the left channel of the audio and one person in the right channel of the audio, it will treat those as two different speakers if you turn on stereo diarization. So if you mix your audio to be one person per channel, you can very cleanly and very easily get your content diarized. If you want to do it from a technical way, PyAnnote, if you're going to sign up on Hugging Face if you're going to give them your information, if you're going to get the API key. WhisperX and Insanely Fast Whisper are the two that are going to support Pionote. I personally like Insanely Fast Whisper and WhisperX. The way that I run Insanely Fast Whisper is not the code that we saw before. If I show you the code that we saw before for Insanely Fast Whisper, this is what, 200 lines of code, 700 lines of code? It's awful. It's terrible. I don't want to run all of that code. So what I do instead is I use the command line version. And the command line version is just very simple, where it says, here's my file name, device ID MPS, because I'm running it on an M1, M2, or M3 Mac. I say, here's my transcript path, and then I give it my Hugging Face token. It uses my Hugging Face token to go out and get Pionote in order to do the diarization. If you well, I mean, all of this is a real pain in the ass, though. I'm going to be honest. Mac Whisper is so much easier for pretty much everything. As long as you're not doing diarization or you're willing to do diarization manually, Mac Whisper is probably the way to go. Alternatively, if you want to do something faster than your computer, maybe you have an older Mac, maybe you have a Windows machine that doesn't support NVIDIA GPUs, like who knows what's happening. One of the other things you can do is you can go on Google Colab. So Google Colab is Google's cloud offering, cloud computing offering, and you can just run code there. And I believe we did that the other day. And if I have a, yes, I will do this. We will do this live. We will do this now. So right here, we have a Transcribe with WhisperX notebook. And this is just going to allow me to say, hey, install WhisperX right here. It installs all the WhisperX stuff. Right here, we're using a T4. T4 is fancy, GPU or CPU is not fancy. When you see all those things that say CUDA, that say float 16, all of that, that means they have a GPU, a video card. So graphics cards are good at playing cool video games and also doing machine learning, because they both involve doing a lot of math all at once. So if you change this to any one of the GPUs, T4 they'll let you use for free. I also have a subscription which lets me use fancier stuff more often. And then you can just run this code, and I'm gonna grab a Hugging Face token. I'll just tokens. Let's see. I'll make a new one. I'll call this delete this. Copy it. Do you like the warning? Make sure to never post them publicly. Sorry, guys. Here we go. Paste it on in there. And then I run it. And so, oh, the file that I'm using, I have to upload the file. So we'll talk a little bit about the file that I'm using in a minute. How many minutes? I'm not sure. It is an audio file. It's the same one that I used in Mac Whisper. It's that transcription. It is a woman talking to an 11-year-old girl in DC about kind of playground games. It is an audio recording from the Library of Congress. So right now, it's probably downloading the Whisper model. Great, there we go, which usually takes a little while. So we'll come back to this eventually and see how it's going. Connecting, 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 connecting. Oh, I had some connecting problems at some point in time. Maybe it's still having trouble. Anyway, we'll let that sit for a bit. We'll come back and we'll see how long it took. So if you want to use the cloud, great, go wild, use the cloud. Now, when you are picking all of this, one of the things that you can do along with using these different tools or these different implementations of the Whisper software side of things, or the tool that uses Whisper, you can also use other models. So Distill Whisper is a version of Whisper that has been distilled. It's been made smaller, it's been made faster. Supposedly it's 6.3 times faster, which is a strange way to describe it. than Whisper, and the accuracy rate is, I believe, within 1% for well-recorded audio. So if you want something very, 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 very fast, but also very good, Distill Whisper is probably the route to go through. Now, what else exists out there besides Whisper? If you have been doing transcription or if you have used audio in the past, oh no. Colab is getting so grouchy at me, but it's fine. We didn't need it anyway. So what else is out there besides using Whisper? YouTube transcripts. I will not point out the person in chat who was like, hey, yeah, it's fine to use YouTube transcripts. They're usually pretty good. I put that to the test. So we'll actually see how good YouTube transcripts often are. They are free, they are automatically generated, and they are easy to download. Otter.ai. Who here uses Otter? Who here takes their transcripts and pushes them through Otter or records things live or even Zoom meetings using Otter? Everyone loves it. It's so easy to use. It's probably incorporated in your life in 1,000 ways. Every single time I have people who join meetings with me on Zoom, they always have their little Otter autopilot, and it hangs out and it transcribes things for them and provides notes, and it's so creepy. I don't like it. It costs money, and in theory, it says it does diarization. So that sounds fantastic and amazing. Next up, you might get something a little bit more technical. So Deepgram is a thing that's out there that's pretty popular. They have a model called Nova, and they say Nova, state of the art, state of the art. It is better. It is better than Whisper, and it does diarization, and they have an API. And the best thing about Deepgram is their website is so easy to use. It is the most usable website for trying things out or figuring out how the API works, and it's just spoiler alert, the transcripts are not that good, but the process is so nice that I would probably use it just for that. So let's use all of these. I'm going to use, oh wait, hold on, let's see. Should I talk about this? Yeah, no, it's fine. Back to my beautiful screen share. I'm going to use the same file that I've used before. If we go onto Otter, Otter does this. Speaker 1, speaker 2, speaker 1, speaker 2, speaker 1, speaker 2. If we look at this transcript, now the very first thing you're going to do every time you transcribe something, the way that I did this was I just clicked a button and the button said, import the transcript. I'm not showing you that page because it also has a lot of like secret private Columbia faculty things, emergency faculty meetings, stuff like that. So you're just going to have to trust me that you just drag and drop. And well, how do you play kickball? That makes sense. But something like what kind of game to play kickball jump rope to tower just be at home as? I don't know if that is accurate. I don't know if that is accurate. So you say, okay, maybe that's not the best one. Maybe that's not the best one. What we will do instead is maybe we can go to Deepgram. And so what you do on Deepgram, I'm going to drop this link in Slack because it is very fun if you sign up. And what you can do is you just drag and drop a file. I drag and dropped my audio file later. And on the left-hand side, these are all of the different options you can do. You can say, hey, Deepgram, summarize, detect topics, give me sentiment, reformat it, add punctuation, put things into paragraphs. It does other things like filler words. Do you want when someone says or for it to be transcribed? And you can also click diarization. So if you would like it to split up the speakers, you can split up the speakers. Maybe I'll do that. Why not? You hit run. Oh, it didn't like it because I sat on this page for too long. Change audio file, upload audio file. There's my audio file. What happens if you try too hard to prepare? So when you are using these tools, you have to weigh the idea of, yes, it does this stuff for us, with how well does it do these things for you? And so even though it says it does diarization, or even though it says it does summarization, there's always some degree to which it is good or it is bad. So let's see this. The next excerpt is taken from original tape 296. What kind of games do you play? I play kickball, jump rope, sometimes I just be at home. That's all. How do you play? This seems obviously much, much better than Otter. Team, two team. You're like, huh, I don't think that's right. Who knows? If you listen to it, you would know. But for now, we're just looking at it and kind of getting a vibe check as to whether this is better or not. Already, we're looking at Otter and we're like, Otter, you are garbage. Why are you so bad? Why are you so bad? I also uploaded this onto YouTube, and I'm going to try to download the transcript from that real quick. I uploaded it. I had to make it a video. I used FFmpeg to make it a video, and I don't know how well it did. Where are my subtitles here? Doing it secretly off to the side. Okay. So I'm using a Chrome extension called YouTube Caption. I think there are a ton of these different extensions. I don't really spend that much time downloading transcripts from YouTube manually. Usually I use it using YouTube Caption API, which is a Chrome library, not Chrome library, Python library. But if you look at this, this is the transcript over here. Yep, original tape, 296. What kind of games do you play? Team, two team. You have to have two teams. You have boys on one side, girls on the other. They roll the ball and you kick it. This seems pretty good. This seems pretty good. Even though we've talked trash about YouTube transcripts before, oddly, in this case, they are even better than Otter, which charges you money for them. So good work, YouTube, I guess. And that's all of them. So we used Otter, we used YouTube, we used DeepGram, and we looked at them and we said, this seems good, this seems bad. But you can't just say this seems good or this seems bad. Like AI cannot live or die on vibe checks, because the issue with this sort of vibes idea is, I don't know, like just throw some numbers at it. Tell me how accurate it really is. So what I did, our audio sample is from the Library of Congress. It's something called the American English Dialect Recordings. And it is just people from different ages, from different parts of America, whether it's DC, whether it's Louisiana, whether it's Minnesota, whether it's Vermont, whether they are 11 years old, whether they are 85 years old. And what it is them just talking. So I'm going to play this. I'm going to make sure my audio's off so it doesn't reverb, but this is the transcript that we've been working with, or the audio we've been working with.
The next excerpt is taken from original tape 296.
What kind of games do you play?
Sometimes I play kickball, jump rope. Sometimes I just be at home. That's all.
Well, how do you play?
So it's not the best quality audio that's ever existed in the world. It is someone who has some sort of accent in the way that they are talking. And the reason why we're doing this is because when you deal with people who talk differently, there are huge disparities in the way that automated speech recognition works. And this is something we talked about the other day. The one on the right, yeah, I'll drop the, so if you want the Library of Congress audio, let's see. I don't have the link right here for that website, but I will give you the link to the audio itself if I can find YouTube. Did I close YouTube? Of course I closed YouTube. Great. Give me 1 minute. There we go. So if you go in that Google Drive link, you'll be able to pull that audio down. And oh, I probably have it right here. Great. Here is the other website that I pulled the recordings from. So this is not, this isn't the page I showed you before, but it's great because it shows you little excerpts. You can click play, 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 play. So you can know like what does someone who's a 12-year-old white female from Detroit, Michigan sound like, so you know whether it's something you want to download, as maybe trying to evaluate your model for some sort of bias or some sort of errors. And also, I feel like it's kind of silly to call this bias, even though it is like it's just a model not doing a good job, right? It's a model not working, and it ends up being biased when you're using it for some sort of systemic thing that causes problems down the line. But I think more so, you just want a model that works well, and you want it to work all of the time. And the way to find out whether it's going to work all of the time is try to find these edge cases, right? So if you are trying to see whether it works for people who have an accent that is international, look at this list. We have down here that if you speak Portuguese as a first language and English as a second language, it is going to do a better job than if you speak Korean. Someone who speaks Dutch, because Dutch and English are basically the same language, you end up in a situation where you do much better than something that's Portuguese or someone who's speaking Korean. Then on the left-hand side, we have someone who is black. Their word error rate, we'll talk about those error rates in a minute, is just super, super high. And then you end up being in a bad situation because if we assume that a word error rate of over 0.5 implies a transcript is unusable, then 23% of audio snippets of black speakers result in unusable transcripts, whereas only 1.6% of audio snippets of white speakers result in unusable transcripts. And honestly, later we'll find out that a WER of 30% is even bad enough to be considered unusable. Additionally, we talked about this in the very beginning, because these tools are trained on YouTube videos, and I don't think they come out and say it, but they're trained on YouTube videos. And when people end their YouTube videos, they say things like thank you, or thanks, have a good day, or thanks for watching, and then they just pause and then they end the video. And so what Whisper has learned as a result of listening to all these YouTube videos is that when there is silence, you should transcribe it as thanks for watching, like and subscribe, things like that. So one of the, I think I took the slide out about this, but one of the other things that these models do besides speaker diarization is something called VAD, voice activity detection. And it's just detection of whether someone is talking at that point in time. And it becomes very, very valuable to do voice activity detection when you're transcribing with Whisper, because if there's just silence or if there's music, it's going to make up all kinds of nonsense. It's better to know someone is talking now, let's feed it to Whisper. Someone is not talking at this point, let's not send it to Whisper. And so now we are finally going to get to the point where we are going to evaluate. Oh, we're back to my left only. Who knows? It's a big mystery. I have a magic box that does all of this stuff. Who knows? Okay, so the reason why accuracy is so important is because usually you're taking these transcripts and you're doing something with them. This is a case study from the AP where there's a local television station, and what they wanted to do was transcribe audio or transcribe the audio from videos and do stuff with it to summarize things. And if there are errors, like we know there are going to be errors and hallucinations when we're summarizing. We've talked about this probably every session, right? Somewhere between 3% and 50% error rate for summarization. And if your transcription is also off, then there's a higher chance that something is going to go wrong with your summarization. So you really want your source material to be as good as possible. So you need your transcription to be as accurate as possible. So the way that typically, there are a lot of different measurements, but the way that typically you measure the ability of a transcription software to do a good job is by the word error rate, the WER. So let's say I saw a cat. There are 3 things that word error rate, or maybe 4 things that word error rate is thinking about. Number 1, it's looking at substitution. So if the text is I saw a cat, but it hears I saw a bat, that is called substitution, and it says you did something wrong. Another one is if it transcribes I saw a big cat, and it just hallucinates that big out of nowhere, that is called insertion. And then if it doesn't transcribe something. So let's say it just says, I saw a cat. That is going to be deletion. So these are the three things that it looks at, along with the total number of words in the sentence. So if, for example, I say, I saw a cat, and it got transcribed as, who saw a big bat? It sounds awful. It sounds like it's doing a terrible job, and it is doing a terrible job. But how do we know how terrible of a terrible job it's doing? Is we add together the number of substitutions, the number of insertions, and the number of deletions, and divide it by the total number of words. So in this case, we have two substitutions. We have who instead of I, we have bat instead of cat, and we have one insertion. So we have big where there should not be a big. And as a result, this has a 75% word error rate. So 3 errors divided by total number of words to turn it into a rate, 0.75 or 75%. Now, there are issues with WER as a measurement, and we looked at this when we were looking at bias, I believe. If you have reference of I'm a 5-year-old kid and it transcribes it as I am a 5-year-old kid, that's literally the same. That's literally the same. But, I mean, it's not literally the same. Figuratively, it's the same. Spiritually, it's the same. Semantically, it's the same. But text-wise, it has 2 substitutions, it has 3 insertions, and it has 0 deletions, which gives you 125% word error rate. Whereas on the other side, I have sent a message becomes I haven't sent a message. So semantically, these are completely different things. But because only one letter was substituted, the word error rate is 20%. And yes, word error rate can be greater than 1. And when you get to those situations where silence is transcribed as thanks for watching, or whisper large version 3 starts to just repeat things like nonsense, you get very high word error rates, despite the fact that it's not really the worst error in the world. So word error rate is not the ideal measurement, it's just the most common measurement. And so other measurements can be character error rate. So something like cat versus bat. You say, look, it's not really that bad. The difference isn't so big between cat and bat, but no one ever uses character error rate. Sentence error rate is just saying on a sentence level, how bad did it do? So maybe there's a few sentences that it did really bad on, but you shouldn't say these bad sentences are representative of everything else. There's also MER and WIL, match error rate, word information lost. They do a little bit more math. They adjust for probability. I don't understand word information lost. Everyone's like, go read the paper, but I just know that it's a replacement of RIL, which was something that existed historically, and this is a fancier updated version, but whatever. No one ever talks about those. If you are in your newsroom trying to compare what does the best job, maybe you can use WIL. It's probably going to be the most robust, but we're just going to be talking about word error rate because it's the most common. So if you want to measure word error rate, I didn't even look up how to do this outside of programming because I am a programming person. There is a tool called GWR, and you just import it, and then you say, tell me the word error rate between these two different pieces of text. One thing you do need to do, though, is normalize them. I'm using something from Transformers, which is that Hugging Face library that enables you to use all these models. I don't know why. Oh, I guess it's part of the Whisper subset of Transformers. Still seems weird, though. What the basic text normalizer does is it gets rid of all punctuation. It might do something with numbers, and it makes everything lowercase. Because according to word error rate, if I say cats with a capital C and cat with a lowercase c, those are different words. Obviously, they're not different words, but they count as different words for WER. So you always have to normalize before you do the comparison. If you do not normalize, you end up with very high error rates that are not a realistic representation of what's going on. So I transcribed that little snippet of audio, or that 9 or 10 minute snippet of audio, that conversation from the Library of Congress, with all of these different pieces of software. I use WhisperX, I use Whisper CPP, I use Insanely Fast Whisper, I use Mac Whisper, I pulled it off of YouTube, Deepgram, WhisperX, the base model, not the large model, insanely fast Whisper, the base model. I used Otter.ai, and then I used the tiny version of, I'll make this a little bit smaller. I used the tiny version. Let's see, make that bigger. There we go. The tiny version of Whisper as well. And this is what we end up with. If we are saying that the best possible version is WhisperX large version 3, and you might look at this and say, why is WhisperX large version 3 and Whisper CPP large 3 different? Both of them are using the same model, so they should be the same. But it's not the case. Due to all of the other little extras that exist inside of these tools, they might optimize for accuracy at certain steps. They might optimize for speed. They might do voice activity detection. They might not do voice activity detection. So you end up getting slightly different results, even if everything is using a large version of Whisper. And if we look at this thing from Microsoft, they say a word error rate of 5 to 10% is good quality, ready to use. A word error rate of 20%, you might want to get it a little bit better. And a word error rate of 30 or more is poor quality, and you need to stop doing what you're doing. So if we look at this, we assumed that WhisperX large was the best. And I made that assumption just because I like to use it. But if we compare it to Whisper CPP, that's a 14% word error rate or a 15% word error rate with insanely fast Whisper. And these are all the other large versions of Whisper. And so you're kind of trapped and you're like, what is the actual best model? Because we're comparing all of these. We assumed that one was the best, and we assumed all the larges were going to be somewhat similar. We thought we were just going to be comparing larges with YouTube and Deepgram, Base, and Otter.ai. So what in the world are we going to do? This is an example of what the difference is between WhisperX and Whisper CPP. So we see that the differences aren't that big, but they are big enough that they're going to cause some sort of trouble. And we would like to be as good as possible to know what the best one is. So what we need is the one thing that no one ever wants to do, and that is get a ground truth, get gold data, data that we know is accurate and true. So that was actually not GitHub. This was actually, if you go in Visual Studio Code, if you right-click a file on the left-hand side, you say, I want to compare this, and then you right-click another one, and you can say, compare it with selected. And it's a really nice diff. It's nice. I almost put in here, I knew someone was going to be excited about it, and then I was going to put in a link of how to do a diff in VS Code, but I decided against it. But just look up how to do a diff in Visual Studio Code, and it'll tell you how to do it. So we do need a ground truth, though. As we have looked at in maybe the first few sessions, all we did was we said, look, if you are running these pieces of software, you can't just trust the output. You need to have one column that is, here's what the AI predicted, and one column that is, here's what the reality is. Because you have to compare them to get, you can't just say, I think WhisperX is the best. You have to know that it is the best. And so what you do is you go somewhere and you make someone transcribe something. I am far too lazy to transcribe something, and I also wanted to transcribe like 6,000 minutes of material, and so I wasn't going to do that myself. I used a service called GoTranscript. According to the Wirecutter, it's the best. Can you trust the Wirecutter? I don't know. This is from 2020, so maybe back then you could. And on top of it being the best, if you Google, here's all the services that, like, what should I use to do real human transcription? The other big one is rev.com, and no one likes to work for rev.com, so I figured GoTranscript is at least a little bit better. They also have a really bad API that you can use to upload documents to them or upload MP3s or videos, and it works pretty well. It works pretty well. The transcription world has been decimated by these tools like Whisper. This is the one time I really should have had that slide that says, hey, we got convinced the dog to talk, and someone says I fired everybody. When can I have this dog make medical diagnoses? This has actually happened in the world of transcription. Like, no one is paying people to transcribe anymore because these tools are pretty good. But I will say also that people who do transcription for a living now use these tools to speed up their process. So they first run it through a tool like Whisper, get a rough transcription, and then they kind of edit from there. So you might be dealing with some of the same biases initially, but then in theory, they're correcting them by going over it as human beings. So what I did was, first we're going to look at these two YouTube meetings. They are just city council meetings. I went on YouTube and I typed in, meeting, or maybe I got this from Local View, something like that. But they're just like 2 hour long meetings or so, 1.5 hours, 90 minutes. So it's long enough for if part of it is bad or someone is mumbling at one point, it's probably going to even out for the word error rate. And I just said, hey, go transcript. I'm going to pay someone, like $1.50 a minute to transcribe this, and then I'm going to compare it. That's going to be our gold standard. I'm going to compare it to all of these other tools. And so if I compare Go Transcript to Mac Whisper Large, I have an error rate of about 16%. And unlike previously, where all of the different larges were different, now Mac Whisper Large, and I think that's Whisper X Large, are both a flat 16%. For the other one, I didn't run it through Mac Whisper, but I did compare it to YouTube and Nova 2 from DeepGram. And so we see that the large model got only a 9% word error rate, which according to Microsoft is pretty good. YouTube was 13%, Nova 2 was 14%. So those are both reasonably fine. But for the first video, it was about 22%, 23%, which is considered not fine according to Microsoft. So I ran this through a ton, 5, actually a lot more that you can't see, city level meetings on YouTube. And I just said, what is the word error rate for Go Transcript, the large version of Whisper X, YouTube, and Nova 2? And we see that it widely varies. So YouTube is anywhere from about a 15% error rate to a 32% error rate, whereas the large version of Whisper goes from about 9% to 15%. So YouTube is, between 30% and 14%. And Nova 2, surprisingly, Nova 2 does not do that good of a good job, despite the fact that it is a paid for API that says that it is state of the art. It does worse. So if we look at this, we say, look, sometimes the transcript is going to get up to about 20% word error rate, which is acceptable according to Microsoft, but most of the time it's somewhere around 10 to 15%, which is probably something that we can live with, especially if we're not in a place to pay people to do it. So if we want to download videos, which is something that people want to do all of the time, I think that for downloading videos, for working with audio, for working with video, there are a couple tools that end up being very useful. So this is not necessarily about transcription, but they're just some things I want to throw out there that are useful. So if you want to download videos, you can always go and go to a website that has a lot of advertisements on it. You can download a Chrome extension that is probably going to be bought by someone and then turned into like an information scraper in the future. What I recommend using is a tool called YTDLP. So there used to be something called YouTube DL. YouTube DL got abandoned or it didn't become good anymore. People made a copy of it because it was open source, and then they turned it into YTDLP. YTDLP is perfect. It is incredible. It is a beautiful, beautiful both command line tool and Python tool that you can use to download stuff from YouTube. There's one problem with it though, and the problem with it is that using it is awful, and you never remember the commands beyond download this one video. But thankfully, we live in a world with ChatGPT. And when you want to use command line tools that are complicated, ChatGPT becomes your very, very, very best friend. So you say, look, please, how do I download this? Or how do I just extract the audio? And if you just want the audio of one of these things, it will run it and it will download the audio for you, and then your life will be perfect. also, if you hate to run things on the command line or you hate Python or whatever, there are wrappers that will do this for you. I keep recommending closed source products, but Stature is an app. And here, I'll show you Stature right now. I have it running on my machine. I'll get my slides out of the way. So this is Stature right here. It tries to be like fun and quirky all the time, which I guess is okay. And let's say I want to download this meeting right here. All I need to do is copy that URL, paste it in here, and let's say I just want the audio. Right here, I say, I only want the MP3. I could select all of these other things, all of these formats and things like that. And then I say, download it. And then it just downloads it to my downloads directory. So it's nothing crazy. And it's just potentially for some people easier than running it from the command line. I'm going to pause that because I don't want it to ruin my ability to do coding stuff or to do whatever else. Now, the other tool that I really recommend is FFmpeg. Has anyone here used FFmpeg? FFmpeg is good for everything that involves video. It is also even more complicated than working with YouTube DL because it can do so much stuff. And like, look at that documentation. That documentation looks terrible. It is very ugly, but it is a perfect, incredible tool. So lean very hard on our good friend ChatGPT in order to get all of these commands. It also updates sometimes, so you don't necessarily know whether it's going to work well or not. In that case, you can download something like Shutter Encoder if you're on Windows or FFworks if you are on a Mac. I have not used either of these tools, but people seem to like them on Reddit, and they are also the most attractive. I read so many threads. People say Shutter Encoder is a little too complicated, but it's way better than everything else. So from the chat, am I right in it feels like none of the transcription options available really meet quality standards for transcribing something like a city council meeting? So I think that as someone who spent a lot of time listening to city council meetings, there are city council meetings have the ability to have sometimes people talking in the background, and that either gets transcribed or not transcribed. There are also city council meetings that have awful, awful audio quality, and there's buzzing the whole time. There are also ones where it's generally very good when people are speaking into microphones, but there might be one person whose mic is off or who is far away from their mic or something like that. And so I think that for the ones that are pretty good, I think that it is probably good enough. Like the detail that you're losing with about a 10% word error rate, I don't think is that much. From reviewing things myself, it seems like as long as it is a decent recording, it's pretty good. But this is also my active area of research to see whether it works or not. Alongside what I've talked about before with word error rate and word information loss and things like that, there are other measurements that are more about semantics. And so when you lose all of these abilities, or when you lose all of these words, does it actually make things change? So we looked at the word error rate. That was 20% where it turned have into haven't. And now the sentence is completely different. There are tools that in theory measure the semantic loss as opposed to just differences in words. And that's probably the best kind of analysis to run. I don't have that much experience with those tools. And there's also like every paper about it is like one person writing a paper and no one ever referencing that paper again. So I don't know what the industry standard for it is. So active world of exploration. And between YouTube DLP and FFmpeg, everything ends up being possible. And so I am just going to show you what it is like to run these tools. Let's see, we're going to do a screen share here. And so if I want to, I have, let's say I have this meeting right here, and I want to download it with YouTube DLP. When I ask if I go to, let's see, I'm going to open up OpenAI secretly in another window. Okay. I'm going to say, what is the command line command to run YTDLP and download that? It is going to give me this answer, and I am going to try to run this. I'm going to try to run this right here in my Jupyter notebook. I'm not popping down to the terminal. I'm just using the exclamation mark to run it. When I run it, it is not going to work. No matches found, blah, 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 blah. Oftentimes, when you're trying to run command line commands suggested by GPT and you're trying to run it in a notebook, you need to add quotation marks around anything that seems kind of suspicious. Maybe things with parentheses, things with question marks, things with spaces. You just put quotes around it. So in order to download this video, I just say, download it. And there we go. It's probably going to degrade my ability to stream to you. It was so much faster before. Maybe I have a copy somewhere I can move over so that we can pretend. I'll use this one. Sure. Let's see. Moving things around, moving things around, moving things around. Great. All right, now let's say this successfully downloaded. Congratulations, it downloaded. It downloaded as this right here. City of Mobile City Council meeting, part 2, April 30th, 2024. We again ask ChatGPT, how do if I want to do video analysis? The thing is about video analysis is it's very rare that you're doing video analysis as a video. You don't care if it's a video, you're just looking for something to show up. Maybe you want to extract faces, maybe you want to know the timestamp where something happens, where a car shows up. I don't know what you're looking to do. And so what we're going to do is, if let's say we wanted to pull out a screenshot every 30 seconds, because this is typically the way you're going to do it, even something like Google's Gemini. Google's Gemini, it's their large language model that can do all kinds of stuff. I guess it's not a large language model. It's a multimodal model because you can upload videos and it will analyze the videos for you. But the way that it analyzes the video, it analyzes the videos by taking screenshots of separate frames and then analyzing them independently. So if we wanted to do some sort of analysis of this video, what we need to do is we need to say, hey, use FFmpeg to download. Let's say we wanted one every 30 seconds. If we want one every 30 seconds, we need to take this calculation. I don't want to explain all the details. You just say, hey, go down, or sorry, not download. Take this video every 30 seconds, take a screenshot and save it as this. And again, when you get this code from, oh, I don't have that one. I have the mobile, City of Mobile City Council meeting. And it starts running. And if we hang out here, we see screenshot, 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 screenshot. And so you can say, like, when is this person talking? When is that person talking? One thing that's really good about this, if you want to do this on a know who is talking, usually when we're trying to do an analysis, we are working on just audio, just pure audio. But if you work for, let's say, a TV station and you are attempting to do transcription of city council meetings where people are talking, and it is a fancy TV station that is not just some garbage on YouTube, and it posts the name of the person or the position of the person who is talking at that moment, you could use FFmpeg and scrape the person's name by using OCR, optical character recognition, by just pulling out that little banner at the bottom of the screen to know the name of the person that's talking. So in the way that speaker diarization kind of sucks, that could also help you understand or help you do some sort of automated analysis of who is talking when. Question from the chat, are all YouTube videos downloadable? Yes. Yeah. It doesn't have to be available to download. If you just use YTDLP, it will download them. If it says it cannot download it, just update YTDLP and then it will download it. I think that's the only time I've had issues where I have not updated YouTube DL in like a year and YouTube has changed something on their end. Text to speech, text to speech, text to speech. Okay, so we are past our world of transcription. We're nearing the end. Instead of speech to text, there is also the world of text to speech. And so in the same way that last session, we looked at the chatbot arena, and the chatbot arena was a world where we could say, hey, I am interested in learning what the best model is for doing, for downloading, for doing local large language model stuff. There is also an arena that is just for chatbots. So what I can do is I can type in some sort of text I would like to synthesize, and I can say, our final session of practical AI is almost over. I can't believe it. And then you click synthesize, and it goes out there in the world, and it generates it with 2 different models. So in the same way that the chatbot arena would generate an answer in 2 different models, we now have 2 different models that have answered this. Now, the problem is I can't have my audio on right now because I don't want feedback. So you are going to have to tell me which is better. So I'm going to play the first one.
Our final session of practical AI is almost over. I can't believe it.
And now the second one.
Our final session of practical AI is almost over. I can't believe it.
All right, so which one of these 2 is better? Was it A or was it B? And they don't tell you which one it is because they don't want you to, think, be biased in one or another. We have a vote for, oh no, we have a vote for 2 and a vote for A. So oftentimes the thing that is different between the 2 is something that you either care about or don't care about. And it's difficult kind of at this point. These models are not perfect, especially with text to speech, and figuring out which one is better or which one is good enough, it's tough. It's tough. So we liked XTTS version 2 as opposed to Parler or Parlay TTS. We can look at the leaderboard and we can see style TTS 2, XTTS version 2. The one at the very, very top, though, is 11 Labs. And the thing about these is almost all of these are open source models that you can download on Hugging Face. If we go to Hugging Face and we go to models and we scroll down and we want text to audio. Wait, is it text to speech? No, text to speech, sorry. Text to audio is about playing music. Text to speech, and we see all these different models here. All of these models are, nope, not there, are here except for 11 Labs. Now, why is this, or how is this? Has anyone seen this in the news? So there was a principal in Baltimore, and he got in a lot of trouble for saying all sorts of terrible racist things that was recorded. But then it turned out that he didn't actually say it at all. It was actually a fake. It was an audio fake of having him say all of these things. And it turned out that it was actually someone who worked with him who wanted to pay his roommate for not teaching or not coaching a softball team or something like that. So it was fake and it was bad. And you say, Soma, all of that stuff we just listened to is not good enough to be a fake. It still sounded like a robot a decent amount. And I'm doing this a little bit out of order. The big question everyone's going to have about deepfakes is whether we can detect them. And the answer is kind of, but no. You know in your heart when something sounds like a deepfake. In theory, these models could add little watermarks to them so that a system could listen to it and tell by a certain pattern that it came from AI. But the problem is that if you have a tool that detects whether something is a deepfake or not, there's also something called adversarial reinforcement learning, which is where you can take a model and train it to evade that detector. So it'll generate something and then you'll send it to the detector and it says, yes, this is a deep fake. And then you send it back to the model and say, you're not done yet. Keep trying to make it more fake until it is better. So even though right now we might be able to detect deep fakes, it's basically going to be like a very good fake text in the future where we are going to have no idea what comes from audio or maybe even video generation as opposed to actually being a person. And the place that this is most apparent is 11 Labs. 11 Labs has, I think, by far the best audio model, although I feel like there have been a couple in the past maybe month that people have really liked, but I'm pretty sure they're all private. And the reason why it's so good is because they have text to speech and they also have speech to speech. And so what we're going to do is we're going to look at both of these. And okay. So the way that text to speech works is in text to speech, you type in some sort of text. I can't believe it's the last class of practical AI. I'm happy I'll be able to start sleeping again. And I'll just click generate speech. And this robot voice Alice is going to talk, and you're going to tell me whether she did a good job or not. Oh no. Here, I'm going to refresh. I made one myself. Can I use Brian? Okay. I cloned myself. I cloned my brother. I fed in a YouTube video of myself talking. It only needs to be, I think, like 30 seconds, but it can be up to 5 minutes. And so I'm going to play this and you're going to tell me whether it sounds like me. Why is it freaking out right now? Maybe it doesn't like me. There we go. I can't believe it's the last class of practical AI. I'm happy I'll be able to start sleeping again. All right, how was that? Did it do a decent job? I'm going to click generate again to make it generate another one because it sounds a little bit different every time. I can't believe it's the last class of practical AI. I'm happy I'll be able to start sleeping again. And additionally, this should have worked before, but we can use a pre-made voice like Alice. Ooh, I can switch to 11 Turbo version 2. I don't even know what that is.
I can't believe it's the last class of practical AI. I'm happy I'll be able to start sleeping again.
I always sound sleepy. But the thing is, these are only getting better. They're only getting better. And I recorded this and made this model, I think around Christmas time even. I think I was home when I wanted to, like, I don't know, show my family how crazy the world is right now. But the issue is that text to speech doesn't sound great because the tone is off and it doesn't know when to stress things. And yeah, it's tough. But speech to speech is where it gets crazy. So what speech to speech does is instead of taking text, it takes your voice and your intonation and your timbre and your up and your down and everything about your voice. Sorry, Tam. And it will turn it into a new piece of audio. So here I am recording some audio and it doesn't seem to be doing anything. Oh, I'm going to click this. And so here I am recording some audio for practical AI so that people can see how terrifying it is when this fake thing comes in and says, hi, this is fake. It's awful. It's scary. It's generating and generating and generating.
And so here I am recording some audio for practical AI so that people can see how terrifying it is when this fake thing comes in and says, hi, this is fake. It's awful. It's scary.
I'm assuming that that sounded much more like a real person than when Alice was talking before. But it gets real good when you clone someone else's voice. And so now I have myself, and I'm just going to play a clone of myself. And this is, again, an older model, so it's probably better now. So I'm going to generate speech that should, in theory, just sound like me. I guess it's not very interesting because they could just be playing my own voice back. And so here I am recording some audio for practical AI so that people can see how terrifying it is when this fake thing comes in and says, "Hi, this is fake. It's awful. It's scary." All right, so I couldn't hear any of those because I'm busy hanging out with my audio off. So how did those sound? How was that? I hope I hope I hope it made us a little bit scared, a little bit scared. Um, because that's the end. I would like us to leave on a note of being terrified about everything. It sounds a little nasal. I sound a little nasal. As I give these talks, by the end, I sound as nasal as possible. It's not terrifying, but it's kind of weird. So yes, these tools are amazing and scary, and unlike something like GPT, where they go around saying, "Oh, when you release GPT in the world or allow Llama 3 models out into the world, it is going to destroy the world." I don't think that's going to happen. But when we get to speech synthesis and speech to speech, I don't know if right now we're capable as like the human beings of dealing with a world where anyone's voice can be faked. It's definitely going to lead us to a place not only where people can like attempt to blackmail other people from having like fake speech, but mostly we're no longer going to be able to trust any sort of audio recording. So if you record me saying terrible, terrible things, and then it's released into the world, I can be like, "Oh, that's a deep fake. That's just a deep fake." And I think we're already there with people claiming things are deep fakes when they're actually not. And it's tough. It's tough. So that is our final practical AI. And hopefully, you're all decently terrified, but also you feel a little bit more powerful. So there were ups and downs in this one, I guess. We are able to both make our enemies say terrible things, get framed for saying terrible things, and then transcribe reality pretty easily, even if we have accents. So I'm probably going to host a few more sessions in the future that are about this, that, or the other. I'll be sending out a note with all of the materials for this week, last week, every other week, and letting you know where to go to sign up when there's more stuff happening. If you have questions, email me. If you have things you want to talk about, email me. If you, I don't know, have demands about content that you would like to be made about, everyone wants to talk more about rags, and I hate rags, but it's fine. And so for now, I'm just going to take a break because I have been, so for all of this stuff, like I said last class, not an expert. And I really wanted this time everyone to be able to run Whisper in a way that worked well for them. So I got much better at Whisper over the past 2 days, but did I sleep? No. So if you have ideas about what you would like me to cover in the future, let me know. If you're waiting for an email response from me, I'm sorry. I'll get back to you very soon. And yeah, just let me know if you end up using any of these things, because as someone who is an academic, I very rarely have the ability to actually use these in real life. And so if you say, "Hey, I did a story on it. Here's my story, or here's my research," and I can say, "Oh, that's basically like me doing that research or me doing that story," and it makes me feel like I've actually accomplished something in the world. So thank you so much. You all have been a delight. Thanks for hanging out and for doing all sort of whatever, responding in the chat. And yeah, I think I could do some sort of live office hours or code debugging. The only problem is I don't actually know the answer to any questions, and so it might take a very long time for me to figure things out. But we'll figure some stuff out, and it'll be great. So, thank you all again, and I will see you all. First, I'll be in your email inbox, and then I'll see you all in the future. Have a good one.